Hello, I'm here to talk a little bit about mathematics and COVID-19. This is just a little video to talk about how math relates to what we're doing. So this is something called mathematical modeling. So in stats, we've seen this if you're in my stats class, where if we are trying to figure out if babies prefer helpers or hinderers, we might do a simulation, which is essentially a bunch of coin flips to figure out what normally happens. And this is the same thing. We're going to actually do a simulation to try to figure out what to expect if we do different things with the COVID-19 virus. It's unreasonable to actually do this in real life. In real life, it's coming and it's going to kind of do its thing, but we're going to see how interventions factor into it. This is a page from the Washington Post. Here's the URL. So let's just go through it. You can read it. I'm going to provide a link for you. And this is a basic model. And the model is you have these blue people and these red infected people. And this is the most basic thing, is that they're just going to have people bumping into each other. And if you bump into, if a healthy person in blue bumps into a sick person here in red, then they get sick. So here you have a sick person bumps into a healthy person, like that, like that, like that. So this is pretty basic. But actually what happens is that sick people eventually get better. So we can add another level to this. Sick person hits and becomes better eventually soon after. So this is what happens. Notice that we can use mathematical rules to control what these people do. And now, here's just a bunch of people wandering around in society with some sick people. And notice we can graph this. So you start off with a lot of blue people who are healthy, and then a lot of them become sick, and then they start recovering. So this is a simulation. All they did is they set up a bunch of rules where here's what happens if a person touches. These are mathematical rules. We can run it again, just a couple sick people, and we can see how it infects people. So we get to use mathematics to do this, to try to figure out what happens. And this is what we should expect to happen according to this. By the way, simulations might not be right. They just help us learn. So this is what we'd expect to happen, is that rapidly we get a whole bunch of people sick, and then they start getting better. So this is like a normal curve. Now, the issue for the coronavirus is that this big part right here, the hospitals might not be able to take care of, might not be able to handle this number of sick people. So we're going to look and see what happens if we change things in the model. And the first thing that they do in here is they say, let's quarantine some people. So here, the sick person, we're going to quarantine them, and look, they're all getting infected. But then, oh look, people don't always obey quarantines, and it starts to get off to start spreading to the general population. So you can see it helped the curve. The normalish curve doesn't go up quite so high, but there's still a lot of people. So this is better, right? Up here we had something that looks like that, which is reaches almost the top. Here we only go halfway up, so that helps. Now let's talk about social distancing. So here's social distancing. Notice some of these people aren't moving. Those are the people who are doing social distancing. And notice what's happening. The number is going up much more slowly. So even if the same number of people are infected, the hospitals and clinics don't have to deal with as many at one time. So this is useful. You can see that this is kind of what happens is you get a much slower thing. And now we can look at extreme social distancing where almost no one is moving, and we see that that gets even better still. So these little dots represent people, and they're moving according to mathematical laws. Like you can see that they're bouncing. That had to be programmed in. So this is how mathematics can be used to help with the outbreak. It can help us predict what will happen if we do different things. So here you see that under social distancing, like extreme social distancing, like you don't see much difference at all. And here they are side by side. So free for all, you get this big peak, hospitals are overwhelmed. It's much better with extensive distancing. So there we are. Have a good day. This was just a little video to talk about how we can use mathematical modeling to help learn about things like the coronavirus. They can help us predict what happens. Does this mean this is exactly what's going to happen if we do use extensive distancing? No, because we may have set up the wrong mathematical rules. On the other hand, is it helpful? Yeah, probably. But this is a very simple model, by the way, that was done so that we can see it very visually for this article. There are very complicated mathematical models that will hopefully help us understand it better. Thank you. Bye-bye.